welcome to Game Thinking TV.
Thanks, Amy.
Happy to be here.
All right, I'm so excited to talk to you both about designing with systems. That's one of the questions we get most from students and from clients is really how to think about systems, how to, what it can seem overwhelming. Now, Mike, you've written a wonderful book recently on advanced game design, taking a systems approach. And Raph, your fantastic book, A Theory of Fun, really has systems woven within it without taking them head on. So I wanted to really get both of your wisdom about this so that, if I'm a web developer, I'm a product creator, I'm someone who isn't necessarily a game designer, but I really want to build great software experiences. How should I think about systems?
The first thing, at sort of a very broad level, and it goes well beyond games, is that systems are everywhere. And they're in all of our products, they're in the world, they're in how we see and interact with the world. So from my point of view, it's difficult to see how you could be a product designer or UX designer without thinking about the systems you're creating and interacting with.
Beautiful. What about you, Raph?
Yeah, I think that's absolutely right. Our bodies are systems. We are systems moving around in a world of systems. They're pretty much everywhere. I think the challenge for people is actually learning to see that, right? To recognize when there is a system that they are interacting with, and to learn to think about the often what feels like unpredictable outputs that systems give. And particularly for product designers, especially those who work with any kind of social system, it can feel like random things are happening that they don't understand, when in fact it's mostly a result of system dynamics that can be figured out and worked with and designed with intention.
I think that's a really excellent point, that once you start to see the systems around you in the world and in nature and in the products you create, things start to feel less random. You can start to see the regularities in how your customers are interacting with your product as individuals and as a whole. And so you're not beset by sort of random crises all the time. It's, okay, this is what's happening now because of these changes in another part of the system. So it really helps reduce the chaos in your life, among other things.
Can you give a specific example?
I can give it from a game example, but it was as a product. We had made some changes to a game, and as often happens in games, a lot of our customers were unhappy with it. And it was creating an outsized reaction inside of our company. And we had to take a very close look at what the actual changes were that we made and what their actual effects were materially in the game. And when we did that, what we discovered was there was a whole technological system and a social system interacting together, and we were then reacting to it disproportionately. So we had to be able to say, okay, hang on, the system's fine. We have this brief spike, but it's not going to, this isn't a bad trend that's going to continue upward. We know that because we can see the behavior of the system as a whole. And so we said, really what this is a very few game players having a particular reaction. Let's wait 4 hours and see what happens. And sure enough, it dissipated just fine. But this is the kind of thing where if you're not looking at this as a system, you can say, oh my gosh, this is going off the rails. We have to do something right now. And you're crisis driven again, as opposed to be more design driven and systems driven.
Yeah, my favorite example of a system with unintended consequences was back when we did Ultima Online. And you probably remember this, Amy. For a while, we had a real problem with players attacking other players in the game. And so we tried to create systems that would reduce the incidence of that. And one of those was we created a system where when a player was killed by another player in the game, they could report them and put a bounty on their head. And, the thought was this will generate more gameplay. It will result in good guys chasing after bad guys. And instead, the bounties became a high score table for bad guys, and they competed to climb to the top of the ladder. This isn't that different from the same system dynamic that today we see on, let's say, Twitter or gaming YouTube's algorithms, where people have set up systems that are supposed to be reinforcing good behavior, such as likes or replies or in the case of YouTube, the algorithm driving you towards what's supposed to be interesting content, and instead it's driving people to create outrageous content in order to draw eyeballs. And often that content is not what the platform wants. And so it's the same idea that you can try changing a system or adding a system by putting in rewards into it. And if you don't understand the underlying system behind the rewards, what it is that motivates people, you might get out the exact opposite of what you wanted. But of course, once you understand what's going on, the principle is very simple, right? You are rewarding attention. What gets attention? Outrageousness. Oh, I should design to avoid outrageousness, not reinforce it, right? So that's the kind of insight that systems thinking lets you have.
Beautiful. So let's get down to a few basic terms. Again, it can be really overwhelming to pick up a textbook on systems design and see everything. But I think if you start with the fundamentals and build outwards, it's a lot more accessible. So let's start with some of the really fundamental concepts of building a system, and then we can get into tuning. So we've got concepts like feedback and homeostasis and initial conditions. And then a little later, we've got stocks and flows and acceleration and dampening and, the dynamics of it. Let's start with you, Raph. How would you, when you're rolling up your sleeves and working with a product team, how would you get started in helping them understand systems design and what we're going to start with? Like, okay, to get started, we need to build something, and then that something is going to get iterated and grown, right?
Right.
How do you get started, and what terminology do you use to explain that?
Well, I don't jump straight, for novices, I don't jump straight to the advanced terms, right? I mean, the vast majority of the time when you're doing product design or game design, you're actually designing systems by analogy or outright imitation, frankly, right? So when people do systems design, most of the time they copy a system that's already out there. And that's not a bad thing. It's particularly not a bad thing when doing systems design, as long as you understand that system fairly well, because it also means if you understand it well, you understand what are the kinds of unpredictable things that it gives, what are the behaviors that tend to arise, right? So you are not generally starting with a blank canvas. If you're doing social software, oh, I'm going to need muting, and I'm going to need identity, and I'm going to need profiles, and that is a good thing, right? Incomplete copying can be worse than not being thorough, actually. For example, leaving out muting and blocking, right? So starting out by analogy, starting out by looking at things that are already there is super important. It helps train you in system analysis, for one thing, which is super valuable, of course. And then once we are at a point where we can look at the system in a bit of a more analytical mode, diagramming is usually my answer. And that is where you do start to run into the terms, which I will let Mike explain in much greater detail. But I think it's important, even if Mike now overwhelms you with terms, I think it's important to realize these are all concepts that are pretty familiar to us, right? Like we understand systems on kind of an intuitive level. I often say they're like the mobiles that we hang over a baby's crib. They are things that exist that have these interconnections, and we poke and prod them all the time to learn how they wiggle. So we have understanding of something like homeostasis, the fact that the mobile will in fact settle back into position over time, right? We have understanding of these concepts, even if we don't necessarily know the terms. So simple diagrams can be a huge aid in understanding how these things work, but don't feel overwhelmed by the terms. They're actually terms for very familiar things.
I love it. All right. So, Mike, do you want to
Sure. I'll just
introduce
add,
us to some basics?
well, sure. Let me start with this. When I'm starting to talk to people, whether it's clients or students or even myself, like I'm starting a new project or I'm working with someone else, I tend to start on the experiential side, especially with product design. What is it you're trying to get here? What is it? What is the end that you want the user to walk away with saying, I did this, or I had this experience, or I was able to get this task done? And that's not the only place to start, but typically with product design, I find that's a really good place to start. And then decomposing that down using some of the methods that Raph mentioned, and typically we go from ideation into feature design, but before you get to feature design, really it's okay, but how do these things work together, and what is it that the user is trying to do? What's their state, what's their mental state, and what's the product state, and how do those things communicate together? How does the user and the product communicate together? That then gives us one of the core concepts of the system, which is the loop, which is that one thing talks to another thing, and that thing talks back or talks to a third thing, which then talks back. And so you have this looping. I do this a lot in my class, that kind of motion. But exactly. To get down to some of the basic terms, again, like Raph said, these are really commonly understood at an intuitive level. You can look at a bathtub. A bathtub has a certain amount of water in it. A bathtub is a stock, and you can think of like a stock pond for fish. And there is a concept that sounds abstract, but it's really not that hard, which is state. And that's essentially how much water is in the tub right now. There are 5 gallons of water in the tub. That's the state of the tub. Then you have a source, which is pouring water into the tub, and a sink or a drain, which is taking water out of the tub. So from that, you get flowing water through the tub. Now, if you have a bunch of bathtubs, a bunch of different tanks or something that are connected together, that can start to form a system if it forms a loop. Without a loop, there's no system. But if you have, for example, a water wheel, that it creates a system as it interacts with the creek as the wheel turns. And as the water on one side drives the wheel down, more containers are coming up, more little buckets are coming up, and so you get more water into those buckets and the wheel turns. Those are the real basics of a system. The things that I teach a lot are, I talk about parts, loops, and wholes. So you don't have a system if you don't have a loop. Within the loops are different parts or objects, like the bathtub, for example. And then you have to keep in mind the whole experience, the whole thing that you're trying to do here, especially with a product application. But this is true whether you're talking about a bunch of fireflies interacting or a flock of birds. The flock is the whole. The parts of the individual birds and the loops are how they interact together to create the flock. So again, we see this in nature, in people, and certainly in product design. And I mean, I can go into a lot more detail, but I don't want to overwhelm people because it does get overwhelming quickly with feedback and interactivity. You mentioned homeostasis. That's one of my favorites. You have things that naturally balance out or things that accelerate. And again, there are common examples. If I'm heating up an oven, less heat is applied as I get closer to my target temperature. That's a balancing loop. Or if I'm getting compound interest, the more money I have, the more interest I get, the more interest I get, the more money I have. And that builds up on itself. So we see this in all different kinds of situations.
So you said there's no system without a loop.
That's correct.
So as a software developer, how do I tell the difference between a feature and a loop?
Well, features often exist within loops.
Good.
But
Okay.
the biggest loop that we see in software is between the software application and the user. The user has an intent. They have something they want to get done. They see some affordance or some call to action in the product. They do something. The product does, munches on that, does something with it, and then gives the user feedback. And then the feedback then changes the user's next intention. If any one of those pieces is missing, if the user, I almost want to say player because I say player all the time, but if the user can't see a button to press or anything to do, then they can't enact their intention. Or if they don't know what the software does, they can't form an intention. And if the software doesn't have any way of working with the user's input, it can't do anything. And if it doesn't provide any feedback, like for example, a simple thing like when is my file being done loaded? Is there a loading bar? If there's not, as a user, I have no idea. So there has to be this entire loop between the user and the software. And then within the software, there are multiple loops, multiple features. The thing I look for in systems is whether something forms a system or not is, does it just go part 1, part 2, part 3, and you're done? And that's nicely linear, and a lot of things are like that, which is great. It makes our lives easier. But if you have part 1 affects part 2, which affects part 3, which then affects part 1 again, now you have a loop. Now you have a system. In game terms, this can be, I fight a monster, I get some gold. That makes with that gold, I can buy more stuff, and that makes my character stronger, so I can fight bigger monsters. You have a nice loop there. In a process application, it might be I finish processing one part. I'm thinking like a chemical process. One part of my process, which then enables the next part to happen, which enables the first part to happen again if there's like a catalyst involved or something. That's probably not the clearest example, but part of the problem here is that a lot of the tasks we have in our modern professional environments have been linearized. They've been made linear when they aren't naturally linear. And so you sort of go from start to finish and have to go all the way back to start again. When there are often cycles, natural cycles in our day, in our work that we're not taking advantage of because the software hasn't been designed with the user systems in mind.
That's awesome. Raph, you want to jump in?
Yeah, I think the telltales for me, when you're looking at something from the outside and saying, is this a feature? Is this a system? It does come back to whether, as you do things, the environment changes, as Mike said. In particular, you change, or other things that seem distant from it change. Telltales that you're working with something that is a system under the hood would be if there's any form of progression to it, right? So that's an immediate, if there's a ladder to climb, a scale to measure, a bar to fill, a word count, you're dealing with a system. Because one characteristic of systems is meters that increase, and sometimes increase and decrease and move on, right? Linear processes don't give you things that you can just count that way, right? So even though we might think of an assembly line, for example, as being linear, I started at the beginning, I run all the way to the end, and at the end, it's actually a process built out of a whole bunch of loops with lots of dependencies in it. And we're measuring how that system works by how many cars get built or pens or whatever, right? So a really good sign that there's a system is that there's some kind of incrementing value there that people can look at. That tells you, this isn't going to just be a feature, right? And if you think about this in terms of software, right? The process of writing is actually a systemic one. There are lots of things that feed back. And so when you look at tools dedicated towards writing, they tend to have a lot of statistics for you to look at, word count, and ones like Scrivener let you rearrange parts and pieces, which indicates to you, I'm actually engaging a cyclic process of writing, revising, coming back. And there we have a loop. If it's social software, you see all of these measurements around things like numbers of friends, recencies of interactions, clustering of friends into closer relationships and more distant relationships. That's indicative again. I must be in a system because there's a dashboard of gauges, right? A lot of things really are just features. Grammar checking in the writing app by itself is a feature. There's a system inside it. And I interact with it. I get the little annoying squiggles under my sentence and I fix something, sure. But, we don't necessarily have gauges and dashboards for what's going on inside the grammar checker, right? So we don't interact with that one as a system very much, right? A programmer does, but it's really a feature of the larger system that we're trying to build. And so, dashboards and gauges are a clear giveaway. Senses of progression are a clear giveaway that you're likely dealing with something that has systemic qualities to it. So as a product designer, that's the thing that I would look for to make that distinction.
Now, sometimes people put dashboards and gauges onto something and put progression onto it, but it's very shallow. So listening to that, someone might say, great, those points and badges I'm using, I'm right on.
There are multiple loops here, multiple nested loops. So if I have a leaderboard that no one ever checks, that's a dead end. There's no loop there. I have to have the social desire to go see where am I in the leaderboard, or where am I in my progression. If I'm doing a language app that shows me my progression, if I never check that, or if I can't find it, or if I just have no interest in it, then that is not part of my system. It's not part of the system of me using this application. But as social creatures, we are often motivated by things like that. So if only I can see my badges, and if it's maybe difficult for me to find my badges, then that's very shallow. It's a dead end. It doesn't do me any good. If other people can see my badges, that gives me a little more of a social need to have those. And in particular, if someone can contact me and say, oh, I see by this badge that you did something, now there's a whole new interaction, a whole new system born out of that. And now both of our connections, myself and this person who's talking to me, both of our connections to the product is stronger. And so we're more likely to keep using it. And this has embedded the system, if you will, as a feature in our systemic interaction. So features are at their lowest level black boxes, like a grammar checker. I really don't care what's going on inside the grammar checker. But then you have, you can have an entire subsystem with multiple features in it that becomes a feature of another higher level system. And this is another characteristic that we see of systems all the time, is they're very, very hierarchical, where a part within one system, you crack it open, it's a whole other subsystem with its own parts and its own features inside of it. So to Raph's writing example, which I think we've all experienced, the writing is something, I'm writing something in the moment. I want to check my grammar. Okay, see, I have to fix this. Great, I fixed that. That's a very small part of a loop. That's part of a much larger loop of me finishing this chapter, which is part of me finishing the book, which is part of me, doing something more with that. If I finished it and never thought about it again, there wouldn't be a closed loop system there. It would just be, well, and you're done, and you never think about it again. And that's not systemic.
There has been, of course, over the last, decade and a half now, of course, all of this gamification stuff, all of this slapping of badges and points on everything in a shallow way. And I didn't mean to draw a connection between a dashboard and progression and rewards necessarily, right? Because I'm not thinking, when I mentioned that there's a dashboard or gauges or whatever, that's not the same thing as sprinkling rewards through a system in order to incentivize somebody to do something, right? Numbers that move around are just a natural output of systems. It just happens. But that doesn't necessarily mean that all the numbers are rewarding to a user. So think about your car, okay? A car has a dashboard that actually presents you with an extraordinary amount of numbers, including ones that we often don't think about, okay? We don't even realize we're being given a number. So it's very easy to see numbers like our speed, for example, or how much gas is left in the tank, right? And a car, by the way, is a system. It's a great system to use as an analogy. There are nested systems that are hidden from us. So for example, it turns out it really matters the angle at which the tires are turned, right? That matters a lot when you're in a car, right? There is no gauge on the dashboard that tells you what angle your tires are turned to. But there is a display of that number, a literal one, which is the angle to which you've rotated the wheel is actually a one-to-one mapping with the angle for the tires, right? So there is an invisible gauge under your hands while you are driving, telling you this is the angle of rotation for the car. That connects into an actually fascinating, complicated system that turns this motion into wheels turning, right? But that you don't necessarily need to know about. And that's what we mean when we say there's a black box system down under there. And of course, the angle of the wheels is only one of the many loops. We turn this, it causes the wheels to turn, which then, from there, things scale up. We also need to introduce gas, we need to introduce brakes, we need to introduce a road, all of those other things. And that's the nesting quality that Mike's talking about. However, in terms of just if you were adding shallow badges, right? Shallow badges would be something like, ding, congratulations, you've rotated the wheel 3/4 to the left, right? That's pointless and not something that we need. And an awful lot of efforts at throwing on badges and rewards tend to do it in places where it's just not really that relevant. It doesn't have anything to do with the motivation of the driver, right? I don't care that I turned the wheel that far. What good is it to tell me that, right? Whereas some of the markers of progression in a car that we might think don't matter, for example, the mileage counter, right? The odometer just goes up and up and up. But that's actually super important for assessing things like when you're going to take the car for maintenance, how well have I taken care of it? Look at this, still running after 250,000 miles, right? So the fact that you have a car that you've kept running for 250,000 miles, that makes you feel good. You've done things right. It might actually be appropriate to put a badge on that. And sure enough, the larger scale systemic systems of our world do things like declare your car a valuable antique. And all of a sudden you can take it to car shows and now you get a badge, right? And so it's important to tie rewards back to things that matter to users. But it's also important that systems have the right gauges, the right dashboard, the right meters and counters and whatnot, so that a user understands what they use the system for. A car's dash is designed to help you use the car, not designed to help you understand how a car works. And that's a really critical thing for UX designers who are working with systems.
That goes back to what Mike talked about, the part and the whole. And the
Yes.
whole is really the user using the system.
Yes.
And
the user and the application create a new system together, and that we see that as the experience that someone has using the system. And when we get into social systems, that's where things get really interesting, because then we have the system of me using an application, perhaps to mediate a social experience, and then all of us together, even one level higher than that, making sure that these fit the user's mental model. This is significant. Oh, I drove my car through a snowstorm. Well, that's significant to me. The fact that I rotated my wheel a certain degree or whatever, that doesn't matter. The other one, though, is memorializing things. Or think, when the odometer turns over, we'll go, yay, it turned over. That is, I drove my car this many miles safely. Perhaps that'd be a great thing to have a badge for, as opposed to you've been to the grocery store 25 times. I really don't care. It has to fit both with my goals and with what is significant to me. And this is true in any product. Sometimes I get things that says, you've been our customer for 10 years. Like, gee, that's okay, good. There's some bilateral loyalty there. Okay, great. That's something good to memorialize. And here's a gift for you for being our customer for 10 years. Oh, okay, good. I'll stick around for another 10 years. That's a good way to memorialize and badge something.
yeah, and threaded throughout this whole conversation are the issues of feedback and incentives. So let's go there. Let's talk about incentive systems, because I think that's what people are trying to build when they gamify. They're trying to build incentive systems. And that's a particular kind of a system, right? An incentive system is, a factory might have that embedded within it, but likes are an incentive system.
Sure.
Right? They're a social incentive system, and they're based on feedback. Something that my customers often get very confused about is the difference between feedback and rewards, right? And that's not a clear line. It's not super clear. But I'd love to get, both of you are experts at designing incentive systems, social incentive systems, complex multi-level embedded systems. How do you think about that, and what role does feedback play in there? And maybe we should get a little bit into positive feedback and negative feedback and how that plays out in a system, particularly a social system. So it's really going deeper on what we've already touched on.
Yeah, I actually, even before we do that, I want to caution us and anyone listening, feedback is actually a term that has overlapping, subtly different meanings that people who are comfortable in talking systems lingo pick up which of the meanings it is from context, and people who aren't don't, and therefore get very confused very quickly. And so it's important to make clear, and maybe we should be more precise, even though in practice in the field people aren't precise about this, because it's valuable, I think, to people, particularly novices, to understand that the word is used in different contexts and it ends up meaning something subtly different. They actually have the same root, but when you interact with something, the black box inside change. Like I interact with the car, I hit the gas, I press the pedal, right? Stuff changes inside the black box. In the case of a car, all kinds of complicated things happen. The motor revs, greater volume of gas, all of this stuff happens. Cylinders move, car rumbles, all kinds of things go on in there. Chemical reactions, energy generated, blah, blah, blah. Most of that we don't know about. A more accurate term would be there are state changes that happen in the system, and we need to learn what changed, right? There's basically a difference between the way it used to be and the way it is now. Call that the delta, the state change. And so the system gives us information. It gives us a lump of information. We get to see the RPM rev, right? We certainly hear the rumble, right? If you gun your car, you go, right? Depending on what state the car is in, maybe the car leaps forward. That's pretty clear feedback. We hit the gas, right? We call that stuff feedback from the system, right? In the sense, just like when I ask someone for advice, I get feedback, right? And what that meaning of the word means is, oh, the loop is closing. I did something. Stuff happened magically inside the box, and then I get this lump of information back, right? That's one kind of feedback, and it's that's kind of a very common casual usage. And if one were trying to be more precise, one could break that down actually into it's a state, it's a dashboard of the state. It's specific reports on what changed, like what deltas there were and so on. And if you wanted to be more precise, you'd use phrases like that, whatever works for your team, really, in order to get that kind of feedback across. And then there is the more technical sense of feedback. And in this, we might think about what's going on inside the car, okay? I hit the gas, the car is moving, and it is rolling downhill because I hit the gas. It had been steady, and now it's going, but we're on a slope. If I hit the gas, I know the car is going to speed up. It also turns out that being on a slope makes the car speed up. And it turns out that these two things affect each other. If I hit the gas while I'm on a downslope, guess what? I'm going to get an even larger effect than I thought. Because systems are nested, the kind of feedback where, hey, here's a dump of info, the kind we were just talking about, when something comes back at you, you take it in and you adjust what you're doing, right? Oh, my car started moving. Great. I take it in. Now I build on that and I start turning the wheel, or I let off the gas, or whatever. I make new decisions. Because systems are built out of smaller systems much of the time, what happens inside when one system gives feedback to another system is that they start doing things on their own that we don't even know about, or that we aren't necessarily directly controlling. The technical term for those is that there are positive and negative feedback loops inside the system, right? Oh, I hit the gas and I'm on a slope. These compound in a way that isn't necessarily directly visible. So Mike's examples earlier of as you approach the temperature in an oven, less heat gets put in because you're coming in kind of to the temperature you want, or compound interest in a bank. Those are examples of feedback loops within the oven, within the financial system, right? And it's deeply connected to the other kind of feedback, but that's one of the places that people get confused fastest, because positive feedback, when you say I'm asking for advice, means you heard something good. And positive feedback, when you're talking about system dynamics, means a system that is incrementing values in an ongoing way, where two systems that are moving are causing the system as a whole to gain, the stocks are increasing. Basically, the numbers tend to be going up.
And then the bathtub might overflow.
And then it might overflow. And those are the things that, that's why we have to be cautious with those terms. It's one of these things where they're technically, they're coming from the same place, but particularly to a layperson, they mean very different things. And as we talk about these, we end up using them interchangeably because we know what we mean. Your listeners need to wrap their head around those. A lot of the fancy terms, dampening, accelerating, have to do with what feedback is going on inside the system.
Right.
Yeah.
Good. Thank you. That's good.
We've got guitars on the wall. Classic kind of feedback. You play a note on the guitar. It goes into the microphone, which comes out the speaker, goes into the microphone, comes out the speaker, goes into... That's a runaway loop, and you get a squeal, and then you get Jimi Hendrix, right? That is actually a positive feedback that's running away from you, which is why musicians call that feedback.
That was awesome. Do you want to jump in, Mike?
Sure. I think you can abstract this out in a lot of cases, especially in product cases, to think about what does the user know about what's going on. To go back to the oven example, the oven may be heating up, and it may be, that internal system is having the internal feedback where it's applying less heat because the thermostat is closing. But if there's no feedback to me as the user to say, what is the temperature, then I have no idea what's going on. Is the oven heating up? I don't know. And that it actually happened this last Thanksgiving, and that was really difficult because we had no idea that our oven wasn't working. So that's a bad thing when that happens. And with any product application, if the user isn't getting some understanding of what's going on inside the black box of the product and how its state is changing, then they can't update their own mental model to create new intentions than to you continue using the system. They just get stuck. We've all seen variations on the spinning wheel of death, where it's something on the computer is spinning. Is it loading? Is it copying? What is it doing? I'm not getting any feedback. I can't form my next intention based on this to go further with it. Worst of all, the application completes something successfully, and the application designers think, great, we did a good job there, but they never tell the user. And as a result, the user has no idea what state changes have happened inside the application, so they can't update their model and again, continue at the sort of the highest level of the system with their interactions with the application. So having appropriate feedback, and this is not not overwhelming feedback. I used to run this as an exercise in usability classes. The car dashboard example. What information is shown there? What information is available but isn't shown there, and what information is not shown there at all? I don't need to know. I don't need to have on my dashboard how to change a headlight, at all times. I only need that very rarely. So that's tucked away someplace. I might want to know if one of my tire pressure is low, but I don't need to know, is it at 38 PSI instead of 42? I just need to know, hey, it's a little bit low. So there's a very simple bit of feedback there. So you can give too much information. You can give too much information too fast and really overwhelm the user because they just mentally can't keep track of it all. Or you can give not enough feedback. So this actually, believe it or not, takes us back to homeostasis in that as an application designer, you want to make sure you're in that Goldilocks zone of giving the right amount of information for the user's context at that time. And that takes us to things like A brand new user is going to have a much lower tolerance for having a lot of information thrown at them. So you want to give them just a few key pieces of information, while an expert user really wants to have a lot going on. I mean, I don't know how race car drivers do it, but they may well, in fact, want to know if it's 38 psi versus 42 psi. So you have someone who's far on that end, on the far expert end, and they can really take in a lot of information. They want to have all that at their fingertips. This is one reason, for example, why new users tend to appreciate point and click or tap kinds of interfaces, where an expert says, "No, take that away. I want to have the command line. I want to have everything right that I can do without the application getting in my way." So from the designer's point of view, part of their task is to understand who their users are and what kind of conditions they're operating under, and what kinds of feedback and how much feedback to offer at any given time in any given context. And that's not a static quality. That changes over time with different users.
Awesome. So you're really talking about that second kind of feedback that Raph was spelling out, which is the feedback between a program and a user.
Yeah, there are some really important distinctions there, but I think we can look at them if you see the system as a series of nested systems. One of the systems is the user interacting with the application, and then there's also, but within each of the user and the application, there are multiple loops happening, and so there's multiple kinds of feedback going on at different levels. The primary one, I guess, especially from a product designer or a UX designer's point of view, is the interaction between the application and the user. Certainly, from an overall systems perspective, we need to think about what are the systems going on inside the application, inside the black box, and what's the feedback there. And even there, you can have, in straight programming terms, if I have a function that doesn't return a value, I may not know. The rest of the program is getting no feedback about what happened inside that function. So there's lots and lots of different levels of this, and then there's the complete other side of it, which is on the user side. I, as a designer, need to be thinking about what's going on inside their head. What's their context for doing this? Sometimes this is purely skill-based in terms of, do they have the understanding of what's going on in this process? And that goes all the way up to their social setting, their emotions. I worked on a series of medical products where physicians really need to use this product and didn't want to do it because the product was physically placed in the wrong social context in the hospital. And so one of the big changes we made was we said, take it out of this one room and put it in this other room, and suddenly the whole product was more usable. But that was not the feedback of the user and the application in that case, but it was their entire context, their entire environmental context, and the feedback they were getting from everything around them. In that case, if somebody else walked in the room and saw the physician making a mistake, that was very, very bad from the physician's point of view. So we had to put it in their office where they could make mistakes with abandon and not worry about it.
What? That's like making sure you're driving the right car on the right road.
Exactly.
You don't take your Ferrari up off-roading,
Right.
That's right.
In the time we have remaining, I'd like to talk about and really get both of your practical insights on building and tuning systems. At some point, you analyze systems, you look at existing systems, you understand systems, you diagram systems. At some point, you're going to build them and tune them. My experience has been that designing and first build might be 10%, and then tuning's like 90%. That's been my own experience. I think a lot of UX designers and product designers, et cetera, they're not used to that. They're used to you build the feature and you release the feature. Let's start with you, Mike. And then I also want to get your input. How do you very practically, you work with a lot of students and you've also worked on a lot of projects. How do you go from, okay, we've diagrammed it, now we're going to build it, and especially build the MVP of it, right? Not the whole thing, and then tune it. Talk a little bit about that process and how you as a professional have learned over the years how to do that.
Well, I think something you said just now about how designing it and implementing is 10% and tuning it is either 90%. I think another way to say it is, you might, if you're playing a game of golf and you've never played before, or you're a professional, you might get a hole in one, but that's generally very rare. Most of the time you're going to get closer and closer to your goal sort of iteratively. And in terms of any kind of complex product design, I think it's vanishingly rare that you come up with a system or much less an entire product and you just implement it and it just works. I mean, it doesn't happen. So you need to go into the mindset of, we know where we're going, we know what our goal is, and now we need to iterate to get there. So I think that's really step one, is having a clear vision of what it is you're trying to do. There was a big survey of game teams that had been successful, and their number one thing that came out, statistically speaking, that was a marker of their success was they had a clear, compelling, shared vision of where they were going. So if you're working with a team, that has to be where you're going, where you're eventually going to be, has to be clear and shared amongst everyone. That then allows you to decompose down to say, okay, now with that, we're going to start as small as we can. And one of the things that I've had some success finally with my students is getting to, when I say small, what I mean is create the smallest, simplest loop you can create that is in some way representative, in some very tiny way representative of where you want to eventually be. So I was starting a new game recently, and the smallest loop I could create was you click a button and a bar goes up, and when the bar is filled, you can click the button again. And that's ridiculously small. I mean, that's tiny. But it takes me a little bit in the direction of where I want to go. It's very, very tempting to say, oh, I want to make this huge thing. Yes, I know, you're making this world-saving application, but start small. And then really kind of tying those both together, I think a critical skill for any designer is to be able to see all the different levels of the systems they're creating at the same time. So I have to be able to focus on the minuscule task I'm doing here to create or to implement or balance a loop to say, oh, that value shouldn't be 3.5, it should be 3.75. You get down these tiny, tiny things at the same time, keeping in mind where I'm going with it eventually. And there's multiple levels in there. So I'm adjusting this one number so this subsystem works correctly. So a larger system will maybe work a little more quickly, gives better feedback to the user. The user can accomplish their task better and is happier with our application as a result. It's really easy to get stuck at one of those levels and forget one of them. So you say, great, this thing works, this one function works terrific, but it doesn't tell the user when it's done. Okay, it's not giving proper feedback. So you weren't thinking at all levels. Or the user can get the first half of what they need done quickly, but the rest of it doesn't work at all. Well, again, you weren't thinking the whole process. So it really is, it sounds almost tautological, but designing systemically is itself a systemic process. And you need to look at this in terms of all the levels of the systems you're creating at the same time.
Great. Raph?
I'm going to try to offer incredibly practical, like super, super practical things that I think novice system designers can start with. The first step is a bit of analysis, right? So you've got a goal, you've got a product goal in mind. It almost certainly means that there's objects in there, some sort of thing, okay? There's some sort of thing that people are dealing with. It might be, I want to go from point A to point B. It might be, I want to create this thing. It might be, I want to arrange these things. Whatever that is, doesn't really matter. Make yourself a list of what are the things, like what are the objects, what are the components that are going into this mix, and clump them together by type. Like if it's, oh, I want to arrange these things. You might not need to know what all of the kinds of things are, right? You just need to know things are something I arrange. So you start with that and then ask yourself, what are the numbers that move around? What are the gauges? What are the bathtubs that fill up and go down, right? Ask yourself that. Identify those. Depending on what domain of systems design you're working in, these may have different terms, okay? Like if in economic systems, we call them currencies, right? Right? Currencies are a number that moves up and down. In other systems, we might call them our resources, right? The difference is where things aren't fungible, they're objects. Currencies are literally numbers, they're gauges that move up and down, okay? And sometimes they only go up. Sometimes they go up and you spend them and they come back down, okay? Identify what those are. These are the bones and sinew of a system, okay? These are the things that really make a system work. And one last thing, which is, what are the things a user can do? the verbs, the inputs, the buttons. And you make a little list of those. Right off the bat, if in your process these lists are long, take a step back. Okay? For any given small system, I'll use a rule of thumb here. Think in threes. If you have more than 3 objects, more than 3 numbers, and more than 3 verbs, you might be thinking at the wrong level of granularity. It doesn't mean that there might not be more numbers or objects or whatever in the system, but it means you're either trying to design, you're trying to boil the ocean. The highest level of a car actually only has, I go from point A to point B. How far along am I? How fast am I going? Which direction am I pointing? I'm done. 3 things, right? Like it's small, right? You go deep into a car and sure, now I've got fuel, you know, I have fuel and I have oil and I have all these things interacting. But any given subcomponent, you can probably look at it and get it in that realm of 3. 3 is just a good number for us to wrap our head around, which is why I suggest as you plan, that helps you think at these different levels of granularity, right? Car speed will in fact decompose into lots of systems with lots more numbers. But at one level of design, it's just one of 3. Okay, so that's the first thing. Think about the breakdown. Second thing, keep your analysis, just to keep it straight in your head, each system, keep it simple. And then think about how you can model it. And this doesn't have to mean, although it can, it doesn't mean implementing. It could just mean thinking about what happens, walking through the flows. Okay, so if I add more water to the tub, the level will go up to here. Oh, okay, right? You can walk through that. You can build it in Excel or another spreadsheet program. If you have engineers, you can get them to build a simple toy version of it. And what you're looking for is where are the places where the system's internal feedback causes numbers to go off in various directions. And you ask yourself the questions. Things like, what happens if this number keeps going up forever? What happens if this number goes to nothing? Right? Like those are your first cut questions. What happens if I run out of this kind of thing? Ask yourself, what if this system causes this number to go beyond what I expect? In a bathtub, it turns out, you know, all bathtubs have 2 drains on them. Most people don't think about it, but all bathtubs have 2 drains. There's a second drain located between the bottom and the faucet, so that when a tub gets to a certain point, it starts draining out of the side, right? That's an overflow mechanism. So piece of advice number 4 is bounds. As you set up a system, put boundaries on all of those numbers and gauges, okay? Even if it's just a warning to you, the developer. And that way, even if your system runs amok, you can kind of limit the damage. And finding those bounds can be a question of experimentation. Piece of advice when experimenting. As you say, oh, pushing this button or doing this results in a change. Classic system designer advice. I don't know how to tune it. Work on one number at a time. Always work on one number at a time, because one number, the effect of it will spread if you've got a complex system. So work on one number. Make sure you've got bounds to keep it from going bananas. And if you're not sure what that number is doing, double it or halve it. Okay? Now, that is an old rule of thumb that is actually grounded in, the computer scientists will go, oh, binary search, right? It is, in fact, one of the most efficient ways to arrive at finding something out of a big spread is to keep cutting things in half and go, it's not in this half, it's in this half, it's in this half, right? So cutting and doubling is a very valuable tool for doing tuning on these things. Graphs are extraordinarily useful when you are working on these systems, because the numbers, the things that you're going to be worried about in systems are often around the rate of change. not the fact that something changed. So it's very useful for you as a designer, as a developer, to be able to see rates of change. So give yourself, in your own debugging dashboard, give yourself dashboards that graph things over time so you can see how things moved and changed. Because just watching a single number is often not going to help you tune.
My friend,
Graphs over time.
My friend, the scatter plot.
Yes, scatter plot. This is where some of those weirder Excel sheets come in handy, right? Like the bubble plot, for example, is actually a very valuable one for looking at systems, because most graphs show you 2 pieces of info at a time. And particularly if a system, will often involve 3. So get comfy with bubble plots. You often end up needing them.
I would say even
anyway, those would be my biggest concrete piece of advice. Just to recap: identify your verbs, which are your inputs, the numbers that move up and down, and what you're operating on. Treat each system. Think in terms of this is a smaller system inside of a larger system. Design them or sanity check them individually. Be aware of the relationships, but you can't try balancing the whole thing in one go. It's too complex. So identify subsystems that tend to fall around 3 variables. Simulate, model, do it by hand, spreadsheets. Set boundaries on the numbers to keep them from going bananas. And have a dashboard that you can look at, ideally one that presents values over time. And the last thing, again, just to circle back, make sure you're doing this all with an eye towards the user's intent. So don't forget about the fact that any number you show, you're telling the user this is important. If it's a number that only ever goes up, that is a subliminal incentive to just make it go up. And that might not be the behavior you want. Right?
Yeah.
Right? To hark back to the bounties example at the beginning.
Exactly.
So think about what you choose to expose, because, the mantra inside the startup is you are what you measure. It turns out that's true for a user of anything. They become the numbers that you present to them. They shape their behavior around the feedback you give them. So think carefully about what you present back out and make sure it's in service of the user's actual goal.
Beautiful. Okay, we're just about out of time. Mike, did you want to respond to that?
Well, I was just going to say, if you are designing systems, you need to be comfortable with Excel or with spreadsheets. And it's surprising to me how many people aren't and think, oh, I really am not going to need that. A friend of ours, another game designer, said that a systems designer is someone who can turn a game into a spreadsheet or a spreadsheet into a game. And I think there's a lot of truth to that, just with applications in general.
Awesome. On that note, I think we're going to have a part 2. We're just getting started. Thank you so much for your time and your insights. This was phenomenal.
Thanks very much. It's great to be here.
Yeah, I enjoyed it. Thanks.